So in this, we're going to cover both problems 5 and 6. I don't have no idea why that's there. We're going to cover both problems 5 and 6. And this is the flow rate through the aorta. We've got the diameter of the aorta, and make sure you convert that to radius. The flow is poisson, which means it's not uniform across the diameter or the radius of the vessel. It's actually maximum in the middle and zero at the edges of the vessel where there's friction. If you've ever, I've had the experience with a toddler going out into one of those lazy rivers at a water park, and that's when you really get to experience this for real, because a toddler goes out into the water and is nowhere close to the bottom or the edges and just suddenly goes zipping along the river, while is the adult is in water that is flowing slower around their feet and is not going to be going as fast. And so toddlers just go zipping away from you in these environments, all because the flow is like this. It's poisson. Now, not exactly like what we have in the vessels, but it's still, it's fastest when you're farthest from the walls of the lazy river and slowest at the walls of the lazy river and at the bottom. All right, so now we've got this flow across, and there are two questions in 5 and 6. What's the average velocity and what's the maximum velocity? Well, the average velocity is the easy one to answer. Why is that the easy one to answer? Well, we know the cross section, all right? We know the area of the aorta. The area is just going to be pi, the radius of the aorta squared. So in this case, pi times 0.0125 meters squared. We'll do it in square meters. And then the flow rate, I, is 500 mils per second, which is 500 times 10 to the minus 6 cubic meters per second. I'm sure you know that conversion right off the top of your head. And so we know I, we know A, right? And we can easily then get the what is the average velocity, which is just the average. Oh, it's just going to be I over A. And this, just so you know, equation 1.44 in your book, average velocity is I over pi r squared, right? I over A. All right, so back over here. Oh, wrong one. Back over here. The harder question, or the other question, is what's the maximum velocity, right? So average velocity we just got. What's the maximum velocity? And if you miss this one, it says go to equation 1.45. Well, in 1.45, you've got this equation right here. And this is the piece we're interested in. Actually, I'll circle it. Let me get in here. This is what we're interested in right there. So this right here is just twice the average, right? What is this? This is the function of, this is just a function of 1 minus your distance from the center squared divided by the overall radius squared. And so this goes from 1 when you're right in the middle to 0 when you're out at the edge. And so the maximum that this can be is what? It's this coefficient out front, right? Twice the average is the maximum velocity. So once you've got the average velocity, getting the maximum velocity in Poisson flow is pretty straightforward. Anyway, there you go. Problems 5 and 6, a bonus.